The information provided in this presentation regarding the automotive market, electric vehicle technology, federal and state tax incentives, vehicle pricing, and automotive financing is intended strictly for educational and entertainment purposes. This material does not constitute professional financial, tax, legal, or investment advice. Purchasing a new vehicle, especially one utilizing rapidly evolving technologies like next-generation electric drivetrains and advanced battery architectures, represents a significant capital expenditure and carries inherent financial risks. These risks include rapid and unpredictable depreciation, highly volatile resale values on the secondary market, fluctuating interest rates, and constantly shifting government rebate structures that can fundamentally alter the actual cost of a vehicle. The automotive industry is currently experiencing a period of extreme volatility, and the potential outcomes discussed herein are based on historical trends, current manufacturer supply chain announcements, and market case studies that may not directly reflect your personal financial situation or geographical reality. Viewers are strongly advised to conduct their own independent due diligence, consult with certified financial planners or tax professionals regarding the specific applicability of clean vehicle tax credits to their individual tax liabilities, and thoroughly research localized dealership markups and financing terms before making any capital commitments. We cannot and do not guarantee any specific financial return, overall savings, vehicle longevity, or performance metric based on the information presented in this analysis. The internal combustion engine vehicle sitting in your driveway right now is officially a depreciating liability on a completely unprecedented scale. While the mainstream media spent the last 24 months loudly declaring the death of the electric vehicle, citing an industry-wide EV winter, slowing sales growth, and hesitant consumer adoption, a quiet and ruthless technological arms race was happening behind closed doors. You have been told repeatedly that electric cars are simply too expensive for the average consumer, that the public charging infrastructure across the United States is fundamentally broken and unreliable, and that range anxiety is an unsolvable hurdle for the typical American family making long highway commutes or cross-country road trips. Those historical trends were absolutely valid for the early adopter phase of the electric transition over the past decade. However, the automotive landscape of 2026 is about to violently shatter those preconceived notions and disrupt the entire market. The reality is that both legacy automakers and disruptive technology startups use the recent market lull not to retreat from electrification, but to aggressively retool their operations. They have been completely overhauling their battery chemistries, redesigning their massive manufacturing processes for unprecedented scale, and most importantly, radically adjusting their pricing strategies to capture the mass market. We are now standing on the precipice of a massive consumer shift, and the stakes for the American auto industry and your personal wallet have never been higher. Let us look at the historical data. Just a few short years ago, the average transaction price for a new electric vehicle hovered dangerously close to $65,000, effectively locking out the vast majority of the middle class and creating a stark divide between wealthy early technological adopters and practical, budget-conscious consumers. But something extraordinary has occurred in the global supply chain. Driven by drastic reductions in the cost of raw materials like refined lithium and a massive industry-wide pivot toward more affordable, durable lithium iron phosphate battery architectures, the entry point for high-quality, long-range electric mobility is plummeting at a staggering rate. What nobody is talking about on the evening news is that 2026 is the year the crucial tipping point arrives. It is the year that true cost parity between traditional gas-powered cars and highly advanced electric vehicles is not just a theoretical projection by an economist, but a tangible reality sitting on dealership lots in every state across the country. But here is the high-stakes catch that could potentially cost you thousands of dollars if you are not paying very close attention right now. The automotive market is about to be flooded with dozens of brand new models, all aggressively marketed and claiming to be the ultimate solution to your transportation needs. The terrifying truth is that many of them are completely obsolete right out of the factory gate. They are still utilizing outdated 400-volt electrical architectures that throttle charging speeds, failing to natively integrate the now standard North American charging standard ports, and suffering from clunky software ecosystems that feel like they were programmed in the early 2000s. Buying the wrong electric vehicle today is financially equivalent to purchasing a premium high-definition DVD player mere weeks before the widespread global adoption of streaming video. It is a massive, highly regrettable misallocation of your personal capital. Out of the overwhelming deluge of metal, glass, and lithium hitting American roads this year, there are exactly 5 models that truly matter. 5 specific vehicles that are meticulously engineered to completely rewrite the rules of driving range, consumer affordability, and technological performance. And one of these revolutionary vehicles is coming from a legacy American brand that Wall Street industry analysts had practically written off for debt just 3 years ago. If you make the mistake of signing a multi-year finance agreement on a gas-guzzling SUV or an outdated, poorly engineered first-generation electric car before understanding exactly what is rolling off the assembly lines right now, you will be locking yourself into thousands of dollars of negative equity the exact moment your tires hit the pavement. This comprehensive masterclass is designed to systematically solve the exact paralysis and immense confusion currently plaguing the American car buyer. Today, we are going completely past the superficial corporate press releases, the heavily edited manufacturer promotional videos, and the highly biased dealership sales tactics to analytically dissect the 5 most anticipated electric cars arriving in the United States in 2026. This deep dive analysis will equip you with the critical objective data needed to successfully navigate one of the most volatile and complex consumer markets in modern economic history. We are going to break down the exact battery chemistries each of these 5 specific vehicles utilizes, explaining step by step why the crucial industry shift from traditional nickel-manganese cobalt cells to advanced solid-state research and structural lithium iron phosphate designs will dramatically alter your vehicle's operational lifespan, its peak direct current fast charging speed, and its ultimate long-term resale value on the secondary market. You will learn the complex historical trends of charging infrastructure development and exactly why the monumental industry-wide adoption of a unified charging standard in 2026 permanently eliminates the geographical and logistical barriers that previously held pragmatic buyers back. Furthermore, we will carefully analyze the projected pricing structures for each model, deeply factoring in the intricate complexities of domestic manufacturing requirements and how those strict regulations directly dictate federal tax incentive eligibility. This will ensure you know precisely what these vehicles will actually cost you out of pocket, not just what the deliberately misleading manufacturer suggested retail price claims on a billboard. By the end of this extensive evaluation, you will possess a fundamental, engineering-level understanding of the underlying technologies driving the 2026 automotive market. You will be uniquely equipped to clearly differentiate between a vehicle that represents a forward-thinking, long-term depreciating asset with strong residual value, and one that is nothing more than a desperate, technologically deficient attempt by a legacy automaker to clear out outdated, poorly designed inventory. Whether your primary household priority is maximizing driving range for extensive interstate highway commutes, securing the lowest possible total cost of ownership over a calculated 5-year period, or acquiring the absolute pinnacle of semi-autonomous driving capabilities, the detailed case studies provided here will serve as your definitive strategic roadmap. We are examining real-world data from early prototype testing, analyzing complex supply chain logistics to predict actual, realistic delivery timelines, and aggressively comparing these highly anticipated 2026 models against the reigning market leaders to see exactly where the balance of automotive power is permanently shifting. You are about to discover the precise mechanical and software platforms that will define the next entire decade of American transportation, ensuring that when you finally decide to sign the paperwork and make your next major automotive purchase, your decision is firmly rooted in empirical data, technological foresight, and a complete, uncompromising understanding of the monumental shift occurring right now. Coming in at the crucial number 5 spot on our definitive list is a vehicle that single-handedly represents the most aggressive assault on the dominant market share of midsize electric SUVs to date. We are talking about the newly released 2026 Rivian R2. For the last 3 years, the automotive industry has watched Rivian build an incredible brand reputation with their flagship R1T pickup and R1S large SUV, but those specific vehicles commanded premium luxury tier price tags that effectively alienated the vast majority of the American middle class. The R2 is their ruthless, highly calculated pivot to mass market volume, and it is currently executing a masterclass in strategic market disruption. Let us ground this complex rollout in a highly relatable real-world case study. Imagine Michael, a 34-year-old architectural engineer living in the sprawling suburbs of Denver, Colorado, navigating the automotive market in this current year of 2026. Michael represents the exact target demographic for this specific vehicle. He commutes 40 miles round trip on heavily congested interstate highways every single weekday, but his weekends are completely dedicated to loading up heavy outdoor gear, premium mountain bikes, and extensive camping equipment for off-grid excursions deep into the Rocky Mountains. For years, Michael was essentially forced to choose between highly efficient but purely on-road focused electric crossovers that lacked physical durability, or traditional gas-powered, body-on-frame SUVs that severely punished his personal finances at the fuel pump. The 2026 Rivian R2 is engineered from the ground up to completely shatter that forced compromise. It delivers a highly sophisticated, whisper-quiet highway driving experience, while simultaneously retaining a brutal, uncompromising off-road capability that its direct urban competitors simply cannot match. With 9.6 inches of ground clearance, highly aggressive approach and departure angles of 25 and 26 degrees respectively, and a staggering 4,400 pounds of maximum towing capacity, this is not a fragile mall crawler masquerading as a rugged adventure vehicle. It is a highly capable, purpose-built machine. But here is exactly where you must exercise extreme financial caution and fully understand the complex realities of modern automotive launch cycles. If you have been casually following the mainstream automotive press over the last 12 months, you have undoubtedly seen the relentless high-budget marketing campaigns loudly proclaiming a jaw-dropping base price of $45,000 for the Rivian R2. You must heavily discount that specific marketing noise if you are actively planning to purchase a vehicle this calendar year. The historical trends of electric vehicle manufacturing consistently dictate that automakers launch their most expensive, highest margin configurations first to aggressively recoup their massive initial research and development expenditures. The 2026 reality strictly follows this model. The $45,000 entry-level standard trim, featuring a smaller battery pack capacity and a single rear-wheel drive motor, is definitively locked out of the consumer market until late 2027. What is actually rolling onto dealership lots and into customer driveways right now, in the spring of 2026, is the top-tier R2 Performance Launch Edition, carrying a starting manufacturer-suggested retail price of $57,990. If you are committing that significant level of capital, you need to deeply understand the underlying mechanical engineering you are actually paying for. The R2 Performance is an absolute technological powerhouse that fundamentally embarrasses legacy gasoline sports cars in terms of raw power delivery. It utilizes a highly advanced dual-motor all-wheel drive architecture generating a massive 656 horsepower and 609 pound-feet of instant, zero-lag torque. That translates to a violent 0 to 60 miles per hour acceleration time of just 3.6 seconds. But raw straight-line speed is utterly meaningless if the vehicle cannot manage its thermal energy consumption efficiently. Rivian has implemented a completely redesigned structural battery pack utilizing larger, highly energy-dense cylindrical cells. This monumental shift in battery chemistry and packaging architecture allows the R2 Performance to achieve an official Environmental Protection Agency estimated range of 330 miles on a single charge. Furthermore, we must meticulously analyze the charging infrastructure ecosystem, because this is where the 2026 Rivian R2 completely changes the ownership paradigm for the American consumer. For the last decade, non-Tesla electric vehicle owners were subjected to a highly fragmented, unreliable, and deeply frustrating public charging experience. The R2 permanently eradicates this historical friction by natively integrating the North American Charging Standard port directly into its rear quarter panel. This is not a cumbersome, failure-prone aftermarket adapter. This is native, seamless hardware integration that instantly grants you unrestricted plug-and-charge access to over 21,000 Tesla superchargers strategically positioned across the United States and Canada. You simply plug the vehicle in, the secure digital financial handshake occurs in milliseconds, and the battery begins rapidly accepting a high-voltage direct current charge, taking the pack from a 10% state of charge to 80% in under 29 minutes. We must also critically examine the autonomous driving and active safety hardware, because the landscape of driver assistance has drastically shifted. The Rivian R2 is equipped with a highly sophisticated sensor suite comprising 11 high-definition cameras and 5 long-range radars, all feeding into a massive onboard computational platform to power Rivian's new Autonomy Plus system. Unlike older, strictly reactive cruise control systems, Autonomy Plus is designed to provide extensive hands-free driving capabilities on over 560,000 miles of pre-mapped highways across North America. For someone like our case study Michael, completing a grueling Friday evening commute, this system drastically reduces cognitive load. The vehicle utilizes dynamic adventure lighting with matrix LED headlights that instinctively adapt to oncoming traffic, while the advanced radar modules constantly map the surrounding environment in total darkness to execute automatic emergency braking maneuvers long before a human driver could possibly react. Furthermore, by utilizing the massive battery enclosure as a stressed, load-bearing member of the vehicle's chassis, the R2 achieves an unprecedented level of torsional rigidity, completely eliminating body flex while creating an incredibly robust defensive perimeter to protect occupants during a severe collision. Let us look at another critical case study regarding interior spatial engineering. Consider Sarah, a high-volume real estate agent operating in the highly competitive market of Austin, Texas. Her vehicle is essentially her mobile office, and she frequently transports demanding clients. The R2 delivers a remarkably spacious interior footprint by utilizing completely flat folding front and rear seats, creating an immense, cavernous space. Rivian has completely bypassed third-party projection software in favor of a deeply integrated, constantly evolving proprietary software stack that handles complex route planning by calculating topographical elevation changes, real-time ambient weather conditions, and precise charging station availability. The interior also features incredibly thoughtful utilitarian touches, like a rear glass window that completely drops down into the tailgate, allowing for the transportation of oversized materials. Before committing, we absolutely must address the financial mechanics of acquiring a Rivian R2 in 2026. Because Rivian made the strategic decision to assemble the R2 at their massive facility in Normal, Illinois, and aggressively source their battery materials from localized supply chains, the vehicle is uniquely positioned to capitalize on federal clean vehicle tax credits, potentially altering the total cost of ownership significantly based on your individual tax liability. However, historical trends strongly suggest a steeper initial depreciation curve on the secondary market for first-year production models of a brand new platform. The Rivian R2 is the definitive proof that the American electric vehicle market is rapidly maturing, representing a beautifully engineered alternative for the consumer who demands rugged utility and blistering performance. But what happens when a legacy blue-collar American automaker decides to leverage a century of mass manufacturing expertise to build an electric vehicle explicitly designed to undercut the entire market on price, while packing a revolutionary battery chemistry that the industry thought was still 5 years away? The vehicle sitting at the number 4 spot on our list is going to completely shock you, and it has the absolute potential to fundamentally disrupt everything we currently understand about affordable electric transportation. Coming in at the number 4 position on our definitive analysis is the completely redesigned, fundamentally re-engineered 2026 Chevrolet Bolt, based entirely on General Motors' highly scalable Ultium architecture. For years, the original Chevrolet Bolt was widely considered the ultimate pragmatic choice for budget-conscious commuters, but it was severely handicapped by painfully slow direct current fast charging speeds and an electrical architecture that felt hopelessly trapped in the past decade. General Motors absorbed those harsh market lessons, observed the aggressive historical trends of overseas competitors, rapidly capturing market share with hyper-efficient budget models, and decided to completely rewrite the financial rulebook for American electric vehicle manufacturing. They are not merely launching a new car. They are deploying a highly calculated, mass-market economic weapon designed to obliterate the financial barriers to entry for the working class. To truly understand the massive scale of this disruption, imagine a scenario involving David, a 28-year-old public high school teacher living in the densely populated urban core of Columbus, Ohio, in this current year of 2026. David operates on a strictly controlled monthly budget. The aggressive inflationary pressures of the past few years, combined with historically volatile gasoline prices, have made his daily 40-minute commute an overwhelming financial burden. When David looked at the electric vehicle market just 2 years ago, the math simply did not work. He was completely priced out of the luxury segment, and the few affordable options lacked the thermal management systems necessary to handle the brutal, freezing Ohio winters without suffering catastrophic range degradation. The 2026 Chevrolet Bolt is engineered specifically to solve David's exact logistical and financial nightmare through one monumental technological leap: the aggressive implementation of a localized lithium iron phosphate battery chemistry. We must perform a deep dive into the engineering physics of this specific battery architecture, because it fundamentally alters the potential outcomes of long-term vehicle ownership. For the past decade, the vast majority of electric vehicles utilized nickel-manganese cobalt, or nickel-cobalt aluminum battery cells. Those traditional chemistries provided excellent energy density for long range, but they suffered from 3 massive drawbacks. They relied on highly expensive, ethically complex raw materials. They possessed a lower threshold for thermal runaway, requiring heavy, complicated liquid cooling systems, and most critically, they degraded rapidly if consistently charged to 100% capacity. Automakers actually had to program complex software limits, strictly advising consumers to only charge their vehicles to 80% for daily use to prevent premature battery death. The 2026 Chevrolet Bolt completely eliminates this psychological and operational friction. By pivoting to a localized, domestically manufactured lithium iron phosphate, or LFP, pack, General Motors has integrated a chemistry that is incredibly robust, highly resistant to thermal degradation, and entirely devoid of expensive cobalt. The most critical advantage for a consumer like David is that LFP chemistry actually thrives when charged to a full 100% capacity every single day. The cell structure does not suffer from the same molecular stress. This fundamentally changes the daily utility of the vehicle. When the manufacturer states an estimated range of 275 miles, you are actively utilizing every single one of those miles daily without fear of destroying your long-term residual value. Furthermore, the financial mechanics surrounding the domestic production of this specific LFP battery pack are the exact reason this vehicle is poised to dominate the sales charts. By strategically sourcing the raw materials and assembling the packs within North America, General Motors has ensured the 2026 Bolt qualifies flawlessly for the maximum federal clean vehicle tax credit. But we are no longer dealing with the frustrating historical trends where consumers had to wait until tax season to see that money. Under the updated IRS guidelines fully implemented across dealership networks, that massive $7,500 credit is applied directly at the point of sale. When you combine this immediate point-of-sale rebate with an aggressively targeted manufacturer-suggested retail price hovering around $28,000, the actual out-of-pocket capital expenditure for a brand-new, highly advanced electric vehicle drops into the low $20,000 range. This completely undercuts the vast majority of used, high-mileage internal combustion vehicles currently sitting on secondary market lots. But affordability is entirely meaningless if the daily charging experience is a constant source of frustration. The 2026 Bolt permanently solves this by completely abandoning the bulky, failure-prone combined charging system standard that plagued its predecessor. General Motors has directly integrated the North American charging standard hardware straight from the factory. For a consumer like David, who lives in an apartment building without access to dedicated overnight home charging, this native hardware integration is an absolute necessity. It grants him immediate, seamless access to the incredibly dense network of Tesla superchargers. The underlying software architecture of the Ultium platform handles the complex digital handshake and billing automatically. David simply pulls into a stall, plugs the sleek, lightweight cable into the vehicle and walks away. The vehicle communicates directly with the dispenser, rapidly accepting up to 150 kilowatts of power, pulling the battery from a 10% state of charge to 80% in approximately 30 minutes. This rapid replenishment drastically reduces the time tax previously associated with budget electric vehicles. We must also examine the massive leap in computational power and software integration within the cabin. General Motors has stripped away the highly fragmented, laggy infotainment interfaces of the past and replaced them with a massive, centralized touchscreen powered entirely by the Ultium software stack. This system features native Google integration, meaning highly complex route planning automatically calculates the most efficient path based on real-time traffic data, accurate topographical elevation changes, and precise battery preconditioning requirements. If you are navigating toward a high-speed direct current fast charger in sub-zero winter temperatures, the vehicle automatically begins heating the battery pack 30 miles in advance, ensuring the cells are at the exact optimal thermodynamic temperature to accept maximum voltage the second you plug in. This level of granular thermal management was previously reserved for vehicles costing 3 times as much. The 2026 Chevrolet Bolt represents the ultimate democratization of electric mobility. It is a highly analytical, incredibly deliberate strike against the rising costs of personal transportation, offering practical consumers a meticulously engineered asset that drastically lowers their monthly operating expenditures. By successfully combining an ultra-durable battery chemistry, native access to the most reliable charging network on the planet, and a pricing structure heavily subsidized by immediate federal incentives, this vehicle is not just anticipated, it is absolutely essential for the survival of the American middle-class commuter. But while General Motors is heavily focused on dominating the practical, budget-conscious segment with raw utility, the vehicle holding the number 3 spot on our list is taking a completely different approach. Prepare yourself because an international technological juggernaut is finally unleashing their highly secretive flagship sedan onto American soil, And it features an advanced aerodynamic profile and a proprietary software ecosystem, so incredibly powerful that it is directly targeting the Tesla Model 3 long range with surgical precision. The performance metrics on this next vehicle are going to completely redefine what you thought was possible in a midsize electric platform. Securing the highly coveted number 3 position on our masterclass breakdown is the unprecedented, industry-shaking joint venture between two global behemoths, the 2026 Sony Honda Mobility Afeela. For years, the automotive industry has been desperately attempting to transition from traditional mechanical manufacturing to creating true software-defined vehicles. We have witnessed legacy automakers painfully struggle to write millions of lines of complex code, resulting in glitchy interfaces, catastrophic over-the-air update failures, and deeply frustrated consumers. The Afeela represents a radical departure from this historical trend. Instead of an automaker trying to learn consumer electronics, we are witnessing an absolute giant of consumer electronics, Sony, partnering with the mass manufacturing engineering supremacy of Honda to build a rolling supercomputer from the ground up. Imagine a highly specific scenario. Consider Jason, a 35-year-old senior data architect residing in the hyper-competitive tech hub of San Jose, California, navigating the brutal realities of the 2026 automotive market. Jason spends nearly 2 hours every single day locked in gridlock traffic on the US 101 freeway. He does not view a vehicle merely as a mechanical appliance for point A to point B transportation. He demands a seamless extension of his highly integrated digital life. For Jason, the traditional metrics of horsepower in 0 to 60 times are entirely secondary to computational processing power, network latency, and autonomous sensor fidelity. He is exactly the target demographic that Sony and Honda are aggressively capturing with the Afeela. To comprehend the monumental shift this vehicle represents, we must meticulously dissect the complex digital architecture hidden beneath its highly aerodynamic exterior. The Afeela is explicitly not competing on traditional automotive metrics. It is competing in the realm of raw data processing. The core intelligence of this vehicle is powered entirely by the Qualcomm Snapdragon digital chassis. This is an incredibly robust automotive-grade system on a chip capable of executing a staggering 800 trillion operations per second. We must pause and analyze what that immense processing capability actually means for potential outcomes regarding your daily commute. While competitors rely on limited camera systems attempting to visually guess depth and distance, the Afeela utilizes a sophisticated array of 45 distinct sensors strategically embedded around the vehicle perimeter. This localized sensor fusion network includes high-resolution exterior cameras, advanced ultrasonic sensors, millimeter-wave radar, and most crucially, a roof-mounted solid-state LiDAR system. By utilizing LiDAR, the Afeela physically maps its surrounding environment in three-dimensional space by pulsing thousands of laser beams per second, achieving an unparalleled level of precision in total darkness, heavy rain, or blinding fog. When a competing vehicle relies solely on optical cameras, it is subject to the identical visual limitations of the human eye. The Afeela bypasses these physical limitations entirely. The massive Snapdragon processor ingests the petabytes of data generated by the LiDAR and radar systems in real time, executing complex predictive algorithms to map the trajectory of surrounding vehicles, pedestrians, and potential hazards milliseconds before they become a physical threat. This is not basic adaptive cruise control. This is the foundational hardware required for conditional automated driving, allowing a commuter like Jason to fundamentally reclaim his lost hours on the freeway by legally disengaging from the driving task in pre-mapped, high-density traffic scenarios where local regulations permit. Furthermore, we must carefully examine the interior cabin environment, because Sony has fundamentally weaponized their dominance in the global entertainment sector. The entire dashboard of the Afeela is a continuous, high-definition panoramic screen spanning from pillar to pillar. But the hardware is meaningless without the underlying software ecosystem. Sony has directly integrated the Unreal Engine 5 platform, the exact same hyper-realistic rendering engine utilized in the most advanced digital entertainment on the planet to power the vehicle interface. When you navigate through a complex urban environment, the navigation system does not display a flat, two-dimensional map. It renders a photorealistic, three-dimensional digital twin of your exact surroundings on the dashboard in real time, dynamically tracking the movement of surrounding vehicles, changing traffic lights, and pedestrian pathways. This level of augmented reality navigation completely eliminates the cognitive fatigue of interpreting abstract directions while navigating hostile urban traffic grids. From a rigorous financial perspective, Purchasing a fully realized software-defined vehicle fundamentally alters the traditional automotive depreciation curve. Historically, the moment you drove a physical car off the dealership lot, its mechanical components began to age, and its feature set was permanently locked in time, leading to a rapid, unavoidable loss of capital value. The Afeela actively combats this historical trend through deep, continuous over-the-air software architectures. Because the vehicle possesses heavily over-engineered computational hardware from day one, it functions identically to a premium smartphone. Sony and Honda can continuously deploy massive algorithmic upgrades, refine the autonomous driving capabilities, introduce entirely new entertainment applications, and actively optimize the thermal management of the battery pack long after the initial purchase date. This continuous digital evolution creates a powerful potential outcome where the vehicle actually becomes functionally superior and inherently more attractive on the secondary market 3 years into ownership than the day it was manufactured. Mechanically, Honda has provided the crucial foundational stability required to support this massive digital infrastructure. The Afeela utilizes a highly dense 91 kWh lithium-ion battery pack, integrated deeply into a rigid all-wheel drive chassis featuring a sophisticated double wishbone front suspension and a multi-link rear suspension to ensure dynamic handling characteristics. While advanced aerodynamic drag coefficient modeling, which aggressively manages airflow over the sleek, ultra-smooth exterior panels, projects a highly competitive driving range comfortably exceeding 300 miles on a single charge, the charging infrastructure is equally flawless. Honda has ensured that the Afeela natively incorporates the North American charging standard, granting seamless, plug-and-charge interoperability with the expansive fast-charging networks across the continent, completely insulating buyers from the charging anxiety that historically plagued the market. The Sony Honda Mobility Afeela represents a terrifying reality for legacy automakers. It proves that the future of the automotive industry is no longer dictated solely by whoever builds the best mechanical components, but by whoever codes the most advanced, seamless software ecosystem. It is a highly analytical, surgical strike against the established market leaders in the premium electric sedan category. But while the Afeela is utilizing advanced silicon processors and laser mapping to quietly dominate the daily commute, the vehicle absolutely dominating our number 2 spot is taking a fundamentally different, violently aggressive approach. What happens when the most legendary, unapologetic American muscle car in automotive history completely abandons gasoline, replaces its iconic combustion engine with a massive electric powertrain, and arrives on the street specifically engineered to shatter quarter-mile records and make traditional purists question everything they thought they knew about raw performance? The sheer physics of this next machine will completely alter your perception of speed and power. Securing the fiercely contested number 2 position on our masterclass evaluation is a vehicle that has single-handedly sparked the most intense, polarizing debate in modern automotive history. We are aggressively dissecting the 2026 Dodge Charger Daytona EV, specifically focusing on the hyper-advanced 800-volt Banshee architecture and the pavement-shredding Scat Pack configurations. For nearly 2 decades, the Dodge brand was completely synonymous with massive, supercharged internal combustion engines. They built their entire corporate identity on the visceral roar of the Hemi V8. When they announced the permanent retirement of that legendary engine, automotive purists loudly declared the death of the American muscle car. But Dodge was not retreating. They were quietly rearming. They clearly recognized that the physical limitations of gasoline propulsion had been reached on the assembly line, and the only mathematical way to achieve the next echelon of violent, straight-line acceleration was through the immediate, brutal torque delivery of advanced electrification. To truly comprehend the psychological and mechanical disruption this vehicle represents, imagine Marcus, a 42-year-old Union Line worker and lifelong muscle car enthusiast living in Detroit, Michigan, navigating the automotive transition in this current year of 2026. Marcus has spent his entire adult life modifying traditional gas-powered vehicles. He historically viewed electric cars as sterile, soulless appliances built exclusively for coastal tech workers, fundamentally lacking the raw mechanical aggression he demands from a daily driver. When Marcus lines up his meticulously tuned prior-generation Hellcat against the new 2026 Charger Daytona Scat Pack at a local drag strip, he is forced to confront a terrifying new reality in the laws of physics. The electric Charger does not need to build engine revolutions or wait for a heavy supercharger to force ambient air into an intake manifold. The exact millisecond the driver presses the accelerator pedal to the floor, a massive electrical current instantly floods the dual permanent magnet synchronous motors. Let us deeply analyze the exact power metrics and highly advanced battery architecture that make this instantaneous violence possible. The Charger Daytona Scat Pack currently utilizes a specialized 100.5 kilowatt-hour lithium-ion battery pack, engineered specifically for an unprecedented peak discharge rate of 550 kilowatts. This is strictly not a battery designed purely for hyper-efficient, low-speed highway cruising. It is a rapid discharge energy reservoir built to dump massive amounts of electrical power to the motors in the exact span of a quarter-mile sprint. This translates to a staggering 670 horsepower and 627 pound-feet of instantaneous torque sent to all four wheels through a sophisticated mechanical limited-slip differential. For a driver like Marcus, the result is devastating to his historical worldview. The heavy, all-electric Charger effortlessly launches from 0 to 60 miles per hour in just 3.3 seconds, fundamentally obliterating the gas-powered Hellcat off the line and crossing the quarter-mile mark in an estimated 11.5 seconds without burning a single drop of premium unleaded fuel. But Dodge engineers knew that raw speed was completely useless if the vehicle felt like driving an oversized golf cart. They engineered a highly unique system called the PowerShot, accessible directly via a button on the steering wheel. When engaged, this system momentarily alters the thermal limits of the battery management software to deliver an instant, aggressive burst of an additional 40 horsepower for exactly 15 seconds, perfectly simulating the violent surge of a traditional nitrous oxide injection system. Furthermore, 2026 represents a massive technological pivot for this platform, as Dodge begins integrating revolutionary solid-state battery technology in partnership with Factorial. By replacing the heavy liquid electrolyte found in traditional lithium-ion packs with a solid conductive material, the potential outcomes include drastically reducing the overall curb weight of the vehicle while heavily mitigating any risk of thermal runaway. This fundamentally alters the power-to-weight ratio, addressing the single largest historical criticism of high-performance electric vehicles. However, the absolute greatest historical hurdle for electric vehicle adoption among traditional car enthusiasts has always been the distinct lack of auditory feedback and mechanical engagement. A silent muscle car is a fundamental paradox that alienates the target demographic. Dodge engineered a brilliant, highly controversial solution to this psychological barrier by developing the patent-pending Fretsonic chambered exhaust system. This is absolutely not a cheap, low-fidelity speaker system playing fake engine noises through the interior cabin speakers. It is a physical exterior acoustic amplifier that forces air through a highly engineered, multi-pipe tuning chamber at the rear of the vehicle to produce a visceral, bone-rattling 126 decibel roar, perfectly matching the exact acoustic intensity of the outgoing supercharged V8 engines. Furthermore, to solve the numb, perfectly linear acceleration curve typical of standard electric vehicles, the high-performance Banshee variants utilize an entirely unique erupt multi-speed transmission with electromechanical shifting capabilities. This heavily patented system intentionally interrupts torque delivery for a fraction of a millisecond to provide a distinct, physical jolt to the driver, violently mimicking the aggressive, heavy gear changes of a traditional high-performance automatic transmission. We must also strictly address the immense physical mass associated with large electric battery packs, which historically destroys cornering capabilities and braking performance. Dodge aggressively combats this immense weight by implementing a highly advanced dual-valve adaptive damping suspension system, alongside a fully independent integral link rear suspension. By utilizing a massive track package featuring staggered Goodyear Eagle F1 Supercar 3 tires, measuring 305 mm in the front and an astonishing 325 mm in the rear, the vehicle achieves a level of mechanical lateral grip that completely defies its curb weight. They also installed the largest brake package ever fitted to a factory Dodge, utilizing massive 16-inch Brembo vented rotors clamped by red 6-piston front and 4-piston rear fixed calipers, ensuring the vehicle can repeatedly decelerate from triple-digit speeds without suffering catastrophic brake fade on a road course. From a rigorous financial perspective, transitioning to this specific electric platform alters the entire economic reality of owning a high-horsepower vehicle. Historically, daily driving a 700-horsepower internal combustion engine required staggering weekly fuel costs, frequent synthetic oil changes, spark plug replacements, and expensive supercharger maintenance. By entirely removing these volatile mechanical failure points, the potential outcomes for long-term ownership drastically reduce the total cost per mile. Even when factoring in the premium initial purchase price hovering around $75,000 for the top-tier trims, The operational savings over a standard 5-year automotive loan period are mathematically undeniable. When you arrive at a fast-charging station, the 800-volt architecture of the Banshee model allows the vehicle to pull massive amounts of direct current, taking the battery from a 20% state of charge to 80% in under 20 minutes, completely eliminating the prolonged downtime that ruins weekend track days. The 2026 Dodge Charger Daytona EV proves definitively that the transition to electric mobility does not strictly require the sacrifice of automotive soul, aggression, or raw, visceral excitement. It is a masterclass in utilizing modern engineering to aggressively preserve legacy branding. It successfully bridges the massive psychological gap between traditional blue-collar automotive culture and the inevitable electrified future. But while Dodge is utilizing massive electrical output to violently preserve the heritage of the American muscle car on the drag strip, the vehicle currently occupying our absolute #1 spot is taking a wildly different, paradigm-shifting path. What happens when a disruptive technology company designs a radically polarizing vehicle that transcends the very definition of a pickup truck, creating a heavily armored, dynamically adjusting mobile microgrid that can literally power your entire house during a catastrophic natural disaster, while simultaneously outperforming European supercars in a straight line? The sheer scale, utilitarian ambition, and absolute defiance of traditional manufacturing norms in our final vehicle will completely shatter your understanding of what is mechanically possible on public roads. Claiming the absolute #1 position on our definitive industry analysis is a machine that completely abandons a century of traditional automotive manufacturing principles to create an entirely new category of transportation. We are systematically breaking down the 2026 mass-market iteration of the Tesla Cybertruck. For the past several years, the media narrative surrounding this highly polarizing, brutally angular vehicle was completely dominated by delayed production timelines and early prototype manufacturing hurdles. However, standing here in 2026, the factory lines at Giga Texas have achieved highly optimized volume production, and the massive technological leap this vehicle represents is finally hitting American roads in staggering numbers. This is no longer an internet spectacle or a vaporware concept. It is a highly disruptive, heavily armored piece of rolling infrastructure designed to fundamentally decimate the established full-size pickup truck market. To accurately understand the sheer utilitarian magnitude of this vehicle, imagine a highly specific case study involving Robert, a 45-year-old independent general contractor running a high-volume construction firm in Houston, Texas. Robert operates in a region historically prone to severe, unpredictable weather events that frequently devastate the local municipal power grid, bringing his expensive job sites to a complete, highly unprofitable standstill. For decades, his only logistical solution was to constantly maintain a fleet of noisy, highly inefficient gasoline generators that required constant refueling and tedious mechanical upkeep. The 2026 Cybertruck entirely eliminates this archaic dependency by acting as a mobile high-capacity microgrid. It utilizes an incredibly sophisticated bidirectional charging system known as PowerShare. This is not a basic household outlet awkwardly installed in the bed of a truck. This is a massive 11.5 kilowatt, continuous electrical output system drawing directly from the enormous internal high-voltage battery pack. When the regional power grid catastrophically fails during a severe Gulf Coast hurricane, Robert simply parks his Cybertruck in his driveway, connects the native charging hardware directly to his home electrical panel, and the vehicle automatically senses the grid disruption. In a matter of milliseconds, the truck begins backfeeding immense, perfectly stabilized electrical current into his primary residence. The potential outcomes of this capability are completely life-altering. The vehicle can independently power critical household infrastructure, including central air conditioning units, heavy medical equipment, and massive refrigeration systems for consecutive days without burning a single ounce of fossil fuel. On the physical construction site, Robert utilizes the integrated 240-volt bed outlets to simultaneously run heavy-duty welding equipment, commercial table saws, and high-intensity lighting rigs, fundamentally transforming the physical truck into a silent zero-emission mobile power plant. But the technological disruption of the Cybertruck extends far beyond its massive electrical reserves. We must analytically dissect the exact structural engineering that makes it look like a stealth fighter jet, because the aesthetic design is strictly a byproduct of its highly advanced materials science. Traditional pickup trucks are manufactured using a body-on-frame architecture, where relatively fragile, thin-stamped steel body panels are bolted onto a heavy underlying ladder frame. The Cybertruck completely abandons this historical trend in favor of a stressed exoskeleton, constructed entirely from ultra-hard, cold-rolled stainless steel. This specific proprietary steel alloy was engineered to be so incredibly dense and physically rigid that standard automotive stamping presses would literally shatter if they attempted to bend it into traditional curved shapes. Therefore, the vehicle features brutally sharp, planar angles. The doors are completely impervious to standard shopping cart impacts, severe hailstorms, and even specific calibers of small arms fire. This creates a highly secure, nearly indestructible perimeter for the occupants. Beneath this heavily armored exterior lies an electrical architecture so revolutionary that it instantly rendered the internal engineering of every other vehicle on the road completely obsolete. For over 70 years, the entire global automotive industry has relied on an archaic 12-volt electrical system to power internal accessories, computers, and lighting. As vehicles became increasingly computerized, this low-voltage standard required massive, heavy bundles of thick copper wiring to transmit enough power across the chassis. Tesla executed a masterclass in first principles engineering by completely stripping out the 12-volt standard and forcing a global supply chain pivot to a hyper-efficient 48-volt architecture. By quadrupling the baseline voltage, the Cybertruck requires significantly less electrical current to operate its massive internal supercomputers, drastically reducing the physical thickness and overall weight of the internal wiring harnesses by hundreds of pounds. This extreme reduction in manufacturing complexity and raw material usage directly contributes to a lighter, highly efficient vehicle. This 48-volt leap also enabled the implementation of a true steer-by-wire system, which completely severs the physical-mechanical connection between the steering wheel and the front tires. When Robert turns the futuristic rectangular steering yoke, he is not physically turning a steel steering column. He is sending complex digital signals to highly redundant, high-torque electric motors mounted directly on the steering rack. This allows the vehicle software to dynamically adjust the steering ratio based on vehicle speed. At extremely low parking lot speeds, a tiny fraction of a turn completely locks the front wheels, allowing a vehicle weighing nearly 7,000 pounds to execute incredibly tight maneuvers with the exact agility of a subcompact hatchback. Furthermore, the Cybertruck incorporates active four-wheel steering, dynamically angling the rear wheels to drastically reduce the turning radius and provide uncanny, hyperstable lane changes at high highway speeds. From a strictly performance-based perspective, the top-tier Cyberbeast configuration fundamentally shatters the established laws of physics regarding heavy utility vehicles. By utilizing a highly sophisticated tri-motor all-wheel drive powertrain, the vehicle generates a staggering 845 horsepower and over 10,000 pound-feet of wheel torque. When the launch mode is engaged, the adaptive air suspension automatically lowers the chassis to dramatically reduce aerodynamic drag. The battery management system hypercools the electrical inverters, and the massive vehicle violently accelerates from 0 to 60 miles per hour in a mind-bending 2.6 seconds. It possesses the raw, brute strength to securely tow 11,000 pounds of heavy equipment across mountainous terrain, while simultaneously possessing the blistering straight-line acceleration to deeply humiliate lightweight European supercars on a closed drag strip. The 2026 mass-market integration of the Tesla Cybertruck firmly establishes a new, uncompromising benchmark for what the American consumer expects from a utilitarian vehicle. It successfully merges highly defensive structural engineering, unprecedented electrical supply capabilities, and physics-defying acceleration into a single, highly polarizing package. However, possessing the comprehensive, engineering-level knowledge of these 5 extraordinary vehicles is only the first preliminary step in successfully navigating the 2026 automotive landscape. Because the absolute darkest, most closely guarded secret in the entire electric vehicle industry is not found in the battery chemistry, the aerodynamic drag coefficients, or the rapid charging speeds. The real danger that could instantly bankrupt an uneducated buyer is deeply hidden in the highly complex, mathematically unforgiving world of automotive financing, deeply buried insurance algorithms, and the aggressive secondary market depreciation curves that legacy dealerships are absolutely terrified you will discover. If you attempt to purchase any of the vehicles we have just analyzed without fully understanding the severe financial traps waiting in the finance and insurance office, you are setting yourself up for a catastrophic loss of personal capital. Exactly how are insurance companies quietly manipulating the repair costs of structural battery packs to artificially inflate your monthly premiums? And what is the exact mathematical formula you must ruthlessly demand from your dealership to completely insulate yourself from catastrophic negative equity? The highly secretive financial mechanics of electric vehicle ownership are far more dangerous than range anxiety, and we are going to expose every single one of them. The highly secretive financial mechanics of electric vehicle ownership are far more dangerous than range anxiety, and we are going to expose every single one of them. To fundamentally understand the immense financial peril awaiting the uneducated consumer in the year 2026, we must first aggressively dissect the deeply concealed crisis occurring within the automotive insurance industry. For decades, the actuarial tables utilized by major insurance conglomerates to calculate your monthly premium were based entirely on the predictable repair costs of internal combustion engines and traditional stamped steel frames. When a gasoline-powered vehicle was involved in a moderate low-speed collision, the repair facility simply unbolted the damaged bumper, replaced the crushed radiator, and returned the vehicle to the owner. The transition to advanced electric mobility has completely obliterated that historical repair model, and the insurance industry is actively passing those catastrophic costs directly onto your monthly premium statement. We must deeply analyze the engineering concept of the structural battery pack, a technology we praised earlier for increasing vehicle rigidity and maximizing interior volume. While this design is a mechanical marvel on the assembly line, it is an absolute nightmare inside a collision repair center. Consider a highly relatable case study involving Christopher, a 40-year-old commercial architect living in the heavily congested urban environment of Seattle, Washington. Christopher purchases a highly anticipated 2026 electric crossover, featuring a state-of-the-art structural battery architecture. 3 months into ownership, while navigating a tight subterranean parking garage, he backs into a concrete reinforcement pillar at roughly 8 miles per hour. In a traditional vehicle, this constitutes a minor cosmetic annoyance requiring a $2,000 bumper replacement. However, because Christopher is driving a vehicle where the high-voltage battery enclosure physically serves as the load-bearing floor of the chassis, the kinetic energy from that minor impact is transferred directly into the aluminum extrusion housing the highly volatile lithium-ion cells. When the vehicle arrives at the certified collision center, the historical trends of standard auto body repair are entirely suspended. The facility cannot simply begin hammering out the dent. The vehicle must be placed in a specialized thermal quarantine area due to the extreme risk of a delayed thermal runaway event. A highly specialized high-voltage technician, commanding an astronomical hourly labor rate, must carefully drop the entire structural battery pack to physically inspect the internal cell modules for microfractures. If the manufacturer diagnostic software detects even a fractional deviation in the thermal resistance of a single battery module, the strict factory repair protocols mandate a complete and total replacement of the entire structural pack. Suddenly, Christopher is staring at a $25,000 repair estimate for a low-speed parking lot collision. Because insurance companies operate on strict mathematical profit margins, they are increasingly choosing to declare these sophisticated electric vehicles a total loss, rather than assume the liability of authorizing complex high-voltage repairs. This specific dynamic is causing collision coverage premiums for specific electric vehicle models to skyrocket, completely neutralizing the monthly fuel savings you thought you were securing. But the insurance premium manipulation is merely the first layer of the financial trap. The absolute greatest threat to your personal capital in the 2026 automotive market is the terrifying velocity of the electric vehicle depreciation curve. You must completely unlearn everything you know about automotive resale values. Traditional vehicles depreciated based on physical mechanical wear and tear. Electric vehicles, however, depreciate based on the exact same hyper-aggressive technological obsolescence curve as a premium smartphone or a high-end laptop computer. We are currently living through a period of unprecedented chemical and computational advancement in the automotive sector. Imagine a scenario involving Jessica, a 32-year-old pharmaceutical sales representative operating in Phoenix, Arizona. She requires reliable transportation for extensive regional travel and decides to finance a brand new electric sedan with a traditional nickel-manganese-cobalt battery chemistry on a standard 72-month auto loan. She assumes she is making a prudent, long-term financial investment. However, historical trends from the past 3 years clearly demonstrate that automakers are relentlessly aggressively slashing the prices of their new inventory to maintain market share while simultaneously introducing vastly superior battery chemistries, like the highly durable solid-state packs arriving in late 2026. When Jessica attempts to trade her vehicle in 3 years later, she is hit with a devastating reality. The secondary market places zero value on her outdated battery chemistry, especially when brand new models with superior range and faster charging speeds are selling for less than what she originally paid. She finds herself trapped in severe negative equity, owing $15,000 more on her auto loan than the physical vehicle is actually worth in the open market. This is the catastrophic financial scenario that traditional dealerships are actively hoping you ignore. To successfully combat this immense technological risk and completely insulate yourself from the crushing weight of negative equity, you must ruthlessly control the exact mathematical terms inside the dealership finance and insurance office. For the vast majority of consumers navigating the 2026 electric vehicle market, securing a traditional long-term retail financing contract is a massive misallocation of capital. The primary strategic defense mechanism against rapid technological obsolescence is executing a highly structured, heavily negotiated lease agreement. By leasing the vehicle for a maximum term of 36 months, you are fundamentally transferring the entire financial risk of battery degradation and market depreciation directly back onto the captive finance arm of the manufacturer. You are essentially paying for the exact portion of the vehicle you consume during that specific 3-year window, after which you simply hand the keys back and walk away completely unscathed, ready to upgrade to the next generation of solid-state technology. However, you cannot simply walk into a dealership and accept their initial lease offer, because the finance manager is actively manipulating 3 specific variables to maximize their profit at your expense. You must demand absolute transparency regarding the capitalized cost reduction, the precise residual value percentage set by the manufacturer, and most importantly, the money factor. Dealerships routinely attempt to inflate the money factor, which is the heavily disguised interest rate on a lease, hoping you do not possess the mathematical knowledge to multiply that specific decimal by 2400 to reveal the true annual percentage rate. Furthermore, you must aggressively ensure that the massive $7,500 federal clean vehicle tax credit is being fully capitalized as an immediate point of sale reduction on the gross capitalized cost of the lease. Many unscrupulous dealerships attempt to quietly absorb this federal rebate into their own profit margins by artificially inflating the base price of the vehicle on the underlying lease contract. Understanding the complex mathematics of insurance premiums and lease structures is absolutely critical, but it all becomes entirely irrelevant if you fall victim to the single most devastating trick utilized by legacy dealership networks right now. There is a highly specific, deeply complex federal tax loophole actively operating in 2026 that allows certain buyers to bypass all the strict domestic manufacturing requirements and income limitations associated with the electric vehicle tax credit. Dealerships possess the exact paperwork required to instantly knock nearly $8,000 off your purchase price, but they are systematically trained to withhold this information unless you utter a highly specific sequence of legal and financial terminology. What exactly is this massive federal loophole? How does the commercial fleet provision completely rewrite the rules for everyday consumers? And what is the exact step-by-step script you must recite to the finance manager to force them to legally apply this massive discount to your transaction today? The actual mechanics of securing this hidden federal money are heavily guarded, and learning the exact phrases to demand your capital will change your entire financial reality. The actual mechanics of securing this hidden federal money are heavily guarded, and learning the exact phrases to demand your capital will change your entire financial reality. The entire foundation of this highly lucrative financial strategy rests upon a fundamental, deliberate misunderstanding of the Internal Revenue Code by the general automotive consumer. When the federal government drastically overhauled the clean vehicle tax credit system, they essentially created 2 entirely separate, highly distinct legal pathways for vehicles to qualify for federal subsidies. The first pathway, which is heavily publicized by the mainstream media and relentlessly marketed to the general public, is Section 30D. This is the standard consumer tax credit, and it is a complete logistical nightmare designed specifically to disqualify the vast majority of premium electric vehicles in this current year of 2026. Under the strict regulatory framework of Section 30D, the federal government mandates severe income limitations, completely locking out single tax filers earning over $150,000 and married couples filing jointly who exceed $300,000 in modified adjusted gross income. Furthermore, this consumer-facing pathway implements brutal manufacturer-suggested retail price caps, instantly disqualifying any electric passenger car priced over $55,000 and any electric sport utility vehicle priced over $80,000. But the absolute most restrictive hurdle of Section 30D is the stringent domestic battery sourcing requirement, which dictates that a massive percentage of the raw critical minerals inside the battery pack, such as lithium and cobalt, must be aggressively extracted and processed strictly within North America or by a nation holding a free trade agreement with the United States. If a vehicle fails even a single one of those highly complex metrics, the consumer is instantly denied the $7,500 federal rebate. However, deeply buried within the exact same legislation is Section 45W, explicitly designated as the Commercial Clean Vehicle Credit. This is the massive, heavily guarded loophole that fundamentally alters the potential outcomes of your automotive transaction. The commercial pathway was originally designed to incentivize massive corporate delivery fleets to transition to electric power. Because it was engineered specifically for multi-billion-dollar corporations, Section 45W contains absolutely zero personal income restrictions for the purchasing entity, zero manufacturer-suggested retail price caps on the physical vehicle itself, and most importantly, it completely bypasses every single complex domestic battery sourcing requirement. Here is exactly where the financial mechanics of the modern dealership lease come into play. When you choose to lease a brand new electric vehicle, rather than execute a traditional retail purchase, you are not legally buying the car. The captive finance arm of the automaker, such as Ford Motor Credit or Hyundai Motor Finance, is physically purchasing the vehicle from the factory and essentially renting it to you for a highly structured period of 36 months. Because that massive financial institution is a commercial entity purchasing the vehicle for commercial leasing purposes, they perfectly qualify for the unrestricted $7,500 commercial tax credit under Section 45W, regardless of where the battery was manufactured or how much personal income your household generates. To fully visualize how this aggressive financial maneuver operates in the real world, imagine a highly specific case study involving Brian, a 39-year-old senior logistics director living in the rapidly expanding suburbs of Charlotte, North Carolina. Brian desperately wants to acquire a highly advanced, imported South Korean electric crossover that features incredibly fast 800-volt charging architecture. Because this specific vehicle is assembled entirely overseas and utilizes a battery pack source from a foreign supply chain, it completely fails the strict domestic requirements of the standard Section 30D consumer tax credit. His household income also significantly exceeds the federal limitations. If Brian attempts to execute a traditional 60-month retail finance contract, he will pay the full, unmitigated sticker price of the vehicle, completely absorbing the devastating initial depreciation, hit with zero federal assistance. However, Brian deeply understands the historical trends of commercial lease loopholes. He completely abandons the retail purchase pathway and specifically requests a 36-month lease agreement. The exact moment the dealership processes the lease, the automaker captive finance company is instantly handed a $7,500 check from the federal government for originating a commercial clean vehicle transaction. But here is the catastrophic financial trap that you must ruthlessly avoid. The federal law absolutely does not legally mandate that the captive finance company pass that massive commercial rebate down to the consumer. The dealership and the lender are entirely permitted to quietly absorb that $7,500 directly into their own gross profit margins, while simultaneously charging you a premium monthly payment based on the full, unsubsidized retail price of the vehicle. You must forcefully intervene in the finance and insurance office and mathematically demand your capital. You cannot sit passively at the desk. You must look the finance manager directly in the eye and deliver a highly specific, legally precise statement. You must state clearly, I am fully aware that under Section 45W of the Internal Revenue Code, your captive finance institution is receiving a $7,500 commercial clean vehicle tax credit for the origination of this specific lease agreement. I strictly require that exact numerical amount to be explicitly applied as a capitalized cost reduction on line item 2 of my lease contract right now, fundamentally lowering the gross capitalized cost of this vehicle, or I will immediately terminate this negotiation and walk out of this facility. When you deploy this exact terminology, the potential outcomes in the finance office will drastically shift. The finance manager will typically attempt to deploy highly deceptive deflection tactics. They will look at their complex four-square negotiation worksheet and claim that the federal rebate is already baked into the artificially inflated residual value of the vehicle, or they will falsely state that they have heavily subsidized the money factor to compensate for the missing rebate. You must mathematically reject both of these highly manipulative claims. To fully understand why, you must know that the money factor is simply a heavily disguised interest rate designed to intentionally confuse the consumer. If a finance manager presents a money factor of 0.0029, You must immediately multiply that specific decimal by 2,400 to reveal the true annual percentage rate, which in this case is a staggering 6.96%. A subsidized residual value does absolutely nothing to lower the physical amount of principal capital you are actively financing over the 36-month term, and a lowered money factor is completely useless if the underlying base price of the vehicle, the gross capitalized cost, remains artificially inflated by the exact amount of the hidden commercial rebate. You must aggressively verify the mathematics on the physical contract. The gross capitalized cost, which is the heavily negotiated selling price of the vehicle, must be visually reduced by an explicit line item labeled as a manufacturer rebate or capitalized cost reduction, totaling exactly $7,500. This single, highly calculated negotiation tactic instantly removes massive amounts of negative equity from the transaction, mathematically insulating you from the aggressive depreciation curves we previously analyzed, and fundamentally lowering your monthly capital expenditure by hundreds of dollars. By aggressively utilizing the commercial lease loophole and mathematically dominating the finance manager, you have successfully secured your highly anticipated 2026 electric vehicle, entirely bypassed the devastating depreciation curve, and forced the multi-billion-dollar automotive industry to directly subsidize your personal transportation. You finalize the massive stack of paperwork, take delivery of the pristine vehicle, and confidently drive it back to your suburban residence, entirely convinced that you have achieved the ultimate financial victory in the modern automotive market. But then, you inevitably call a local certified electrical contractor to evaluate your property for the installation of a high-capacity Level 2 home charging station, and you are suddenly hit with a devastating, highly unexpected five-figure invoice that completely shatters your entire carefully calculated monthly budget. The hidden, highly catastrophic home infrastructure crisis lurking silently inside your own residential electrical panel is the final, absolute most expensive financial trap of modern electric vehicle ownership, and we are going to systematically break down the exact, terrifying reality of residential grid constraints and municipal permitting nightmares that the dealership explicitly prayed you would never discover before signing that contract. The entire premise of seamless electric vehicle ownership rests on the heavily marketed utopian vision of simply arriving home, plugging your vehicle into a standard wall outlet, and waking up to a fully replenished battery pack. This is perhaps the most pervasive and mathematically flawed historical trend perpetuated by early electric vehicle marketing campaigns. We must systematically dismantle the mathematical reality of Level 1 charging, which utilizes a standard 120-volt household receptacle, a massive 100 kilowatt-hour battery pack, exactly like the ones found in the advanced 2026 models we previously analyzed, requires an immense amount of physical energy. A standard household outlet delivers a maximum of 1.4 kilowatts per hour. If you arrive home from a long commute with a deeply depleted battery at a 10% state of charge, relying on a Level 1 charger to reach 80% capacity will mathematically require over 50 consecutive hours of continuous, uninterrupted charging. This effectively renders the vehicle completely useless for daily commuting and entirely destroys the perceived convenience of home charging. Therefore, the absolute operational necessity for any electric vehicle owner in the year 2026 is the immediate installation of a dedicated Level 2, 240-volt home charging station. But this is exactly where the catastrophic financial trap aggressively springs shut on the uneducated consumer. To fully grasp the severe residential grid constraints actively threatening your personal finances, consider a highly specific case study involving Thomas, a 46-year-old regional sales manager residing in a beautiful, aging suburban development built in the late 1970s just outside of Atlanta, Georgia. Thomas proudly brings his brand new 2026 electric crossover home and immediately contacts a licensed electrical contractor to install a high-capacity 48-amp Level 2 charging station in his attached garage. He naively assumes this will be a simple $500 transaction involving a few feet of copper wire and a new breaker switch. However, when the master electrician evaluates the primary electrical panel of his home, Thomas is hit with a devastating reality check. The vast majority of American homes constructed before the late 1990s were engineered and built with 100-amp or 150-amp main electrical services. This historical infrastructure was perfectly adequate to power a few television sets, a standard electric oven, and standard incandescent lighting. But when you attempt to introduce a continuous 60-amp circuit explicitly dedicated to an electric vehicle charger, you fundamentally trigger a critical safety threshold within the National Electrical Code, known as the residential load calculation. The electrician performs the strict mathematical formula, factoring in the central air conditioning unit, the electric water heater, the clothes dryer, and the proposed electric vehicle charger, and quickly determines that the home is mathematically oversubscribed. The existing electrical panel cannot physically safely support the massive amperage draw of the vehicle without constantly tripping the main breaker, or, in a severe scenario, causing a catastrophic electrical failure inside the walls of the home. The only legal, code-compliant solution is a complete main service panel upgrade to a modern 200-amp or even 400-amp system. This single, highly mandatory infrastructure upgrade instantly fundamentally alters the entire financial calculation of vehicle ownership. A full heavy-up panel replacement requires extensive labor, highly expensive physical hardware, and potentially thousands of dollars in thick-gauge copper wiring. But the financial bleeding absolutely does not stop there. If the utility company determines that the physical wire running from the neighborhood transformer on the street to the electrical meter on the side of the house is insufficiently sized to handle the newly increased 200-amp load, they will mandate a complete replacement of the service drop. If Thomas lives in a neighborhood with underground utilities, this requires deploying heavy excavation equipment to physically trench through his meticulously landscaped front yard, tear up his concrete driveway, and lay brand new high-voltage conduit directly to the street. The potential outcomes of this specific scenario routinely generate electrical invoices ranging from $5,000 to upwards of $12,000, completely obliterating any theoretical fuel savings Thomas thought he was securing for the next 5 years. Furthermore, the installation process is heavily policed by a highly bureaucratic, mathematically unforgiving maze of municipal permitting nightmares. You cannot simply quietly hire a contractor to execute this work over the weekend. The project requires highly detailed schematic drawings submitted to the local city planning department, rigorous structural and electrical reviews, and multiple on-site inspections by municipal code enforcement officers. In many rapidly growing suburban jurisdictions in 2026, the local planning departments are so incredibly backlogged with green energy infrastructure requests that simply securing the initial electrical permit can delay your home charging installation by 3 to 4 agonizing months, forcing you to entirely rely on expensive, heavily congested public fast-charging networks while your brand-new vehicle sits in your garage physically unable to charge. We must also analytically confront the terrifying, highly secretive crisis actively occurring at the neighborhood transformer level. Even if you possess the capital to upgrade your personal electrical panel, you are entirely at the mercy of the localized utility grid. A standard residential step-down transformer mounted on a utility pole is typically designed to distribute power to 4 or 5 individual homes simultaneously. If you happen to be the third or fourth homeowner on your specific residential block to purchase a high-capacity electric vehicle in 2026, you run the severe risk of mathematically overloading that shared neighborhood transformer when everyone simultaneously plugs in their vehicles at 6 o'clock in the evening. Utility companies are actively combating this by deploying highly complex smart meters and strictly enforcing harsh time-of-use rate structures, intentionally charging you astronomical penalty rates if you attempt to charge your vehicle during peak demand hours. Furthermore, if you purchased a vehicle capable of bidirectional charging, such as the advanced microgrid capabilities we previously analyzed, the installation complexity instantly triples. You are no longer simply installing a one-way power dispenser. You are integrating a highly sophisticated, multi-directional inverter system and an automatic transfer switch directly into your home grid. This requires specialized hardware that physically isolates your house from the main utility line during a power outage to prevent backfeeding electricity and electrocuting utility workers actively repairing the grid. The financial investment required to unlock this highly marketed capability routinely exceeds $10,000 in physical hardware and specialized labor alone. You have successfully navigated the volatile battery chemistry wars, mathematically bypassed the catastrophic dealership financing traps, and completely calculated the devastating hidden costs of your home electrical infrastructure. You now possess the highly elite, engineering-level knowledge required to ruthlessly dominate the 2026 automotive market. But there is exactly one final, terrifyingly critical component we must expose before you sign any legally binding contract. Out of the 5 highly anticipated electric vehicles we have aggressively analyzed today, there is one specific model that is currently concealing a massive, catastrophic software flaw so deeply embedded in its digital architecture that it threatens to render the vehicle completely inoperable the moment its factory warranty expires. Which highly praised manufacturer is actively hiding a ticking time bomb in their underlying code? And what is the exact, uncompromising final verdict on exactly where you must deploy your personal capital this year to completely ensure your financial survival. The exact vehicle possessing this terrifying digital vulnerability is the highly praised software-defined supercomputer we analyzed earlier, the joint venture between Sony and Honda. While the Afeela represents a monumental leap in user interface design and autonomous processing power, it fundamentally introduces a devastating financial risk that the traditional automotive industry has never previously encountered. We must systematically break down the exact mechanical reality of a vehicle that is completely reliant on continuous, heavily encrypted cloud connectivity to function. Historically, when you purchased a mechanical vehicle, the internal computers were highly isolated, localized systems. If the cellular connection failed, the vehicle simply lost satellite radio or live traffic updates. The vehicle still physically started, the transmission still shifted, and the brakes still functioned identically to the day it rolled off the assembly line. The 2026 software-defined vehicle completely destroys that historic isolation. Every single physical component, from the steering rack to the thermal management of the lithium-ion battery cells, is dynamically controlled by a massive centralized operating system that requires a constant digital handshake with a remote corporate server via an internal fifth-generation cellular modem. Imagine a highly realistic scenario involving Kevin, a 40-year-old software developer in Austin, Texas, who purchases one of these hyper-advanced vehicles. For the first 4 years, the ownership experience is absolutely flawless. The vehicle receives seamless over-the-air updates while Kevin sleeps, completely refining the autonomous driving algorithms and optimizing the battery efficiency. However, the exact millisecond the comprehensive factory warranty expires, the financial time bomb violently detonates. Because automakers in 2026 have universally realized that standard vehicle sales no longer generate sufficient long-term revenue, they have aggressively pivoted their entire business model toward massive, recurring software subscriptions. Kevin wakes up to discover that the advanced driver assistance features he previously enjoyed are now locked behind a $200 per month paywall. Furthermore, the underlying operating system detects a fractional anomaly in the high-voltage battery thermal management software and initiates an automatic, highly restrictive limp mode to prevent a potential thermal runaway event. The vehicle fundamentally refuses to drive faster than 30 miles per hour until the code is cleared by a remote server. In a traditional automotive scenario, Kevin would simply tow the vehicle to an independent, highly skilled local mechanic who could diagnose the sensor, replace the faulty $50 component, and clear the error codes using a standard diagnostic scanner. This historical trend is entirely dead in the modern software-defined era. The entire digital architecture of this new vehicle utilizes strict cryptographic parts pairing to aggressively prevent any third-party intervention. The independent mechanic is physically barred from accessing the telemetry data. Even if they manage to physically replace a broken window switch or a damaged suspension sensor, the main computer will completely reject the new hardware because it lacks the specific digital signature authorized by the manufacturer cloud. Kevin is absolutely forced to transport the vehicle directly to a certified manufacturer service center. When the technician connects the proprietary diagnostic equipment, they discover that the physical thermal sensor is completely fine, but the legacy computing module managing the sensor requires a massive, complex firmware rewrite that is no longer supported by the baseline software package. Because the vehicle is outside the warranty period, Kevin is presented with a devastating $5,000 estimate to replace the entire localized computing unit, simply because the manufacturer refuses to push a localized software patch to an older piece of hardware. This is the exact strategy utilized by consumer electronics companies for decades to force planned obsolescence, and it has now been seamlessly integrated into $70,000 depreciating assets. Therefore, we must arrive at the exact uncompromising final verdict regarding exactly where you must deploy your personal capital in the turbulent 2026 automotive market to ensure your absolute financial survival. You must ruthlessly separate your emotional desire for cutting-edge technology from the mathematical reality of capital preservation. If your primary objective is highly predictable, low-cost commuting, and you possess reliable home charging infrastructure, the Chevrolet Bolt utilizing the localized lithium iron phosphate battery chemistry is the definitive, undisputed champion of the budget segment. It offers unprecedented durability and completely neutralizes the rapid depreciation curve through aggressive point-of-sale federal incentives. If your daily life requires heavy physical utility, robust structural integrity, and the highly specific ability to dynamically backfeed power to your residential grid during severe weather events, The mass-market Tesla Cybertruck is a mathematically sound, albeit highly polarizing, capital investment due to its revolutionary 48-volt architecture and proprietary stainless steel exoskeleton that drastically reduces traditional collision repair costs. However, regardless of which specific model you select, the ultimate financial directive remains absolute and completely inflexible. Under no circumstances should you execute a standard 72-month retail finance contract on any electric vehicle possessing a first-generation advanced battery chemistry or a highly complex, untested proprietary software ecosystem. You must forcefully demand the highly structured 36-month commercial lease strategy we previously detailed, aggressively commanding the dealership to apply the exact $7,500 commercial clean vehicle tax credit directly to the gross capitalized cost of the vehicle. By strictly adhering to this specific legal and mathematical framework, you fundamentally transfer the catastrophic risk of localized software obsolescence, highly aggressive secondary market depreciation, and astronomical out-of-warranty structural battery repair costs directly back onto the multi-billion-dollar corporate balance sheets of the automaker. You secure the immediate technological benefits of advanced electric mobility, while completely insulating your personal financial portfolio from the highly volatile, rapidly shifting technological arms race currently tearing the automotive industry apart. You now possess the highly guarded, engineering-level knowledge required to mathematically dominate the new electric vehicle market and successfully negotiate from a position of absolute, uncompromising strength. You know exactly how to defeat the finance manager, how to navigate the residential grid constraints, and precisely which vehicles represent a sound capital deployment based on highly specific case studies. But what happens when you decide to completely bypass the new car market entirely in an attempt to secure what appears to be a massive, unprecedented financial bargain on a lightly used, 3-year-old electric vehicle sitting abandoned on a secondary dealership lot? The mainstream media is actively ignoring the terrifying reality of the rapidly expanding used electric vehicle market and the catastrophic, deeply hidden battery degradation metrics that standard dealerships are legally permitted to conceal from you will absolutely destroy your entire financial future in a matter of days. What is the exact mathematical formula you must utilize to digitally interrogate a used battery pack before you sign the paperwork? And why are thousands of traditional dealerships quietly refusing to accept used electric vehicles as trade-ins under any circumstances? The dark, heavily suppressed reality of the used electric vehicle market is exponentially more dangerous than anything we have discussed today, and exposing that massive financial trap is precisely what we are going to do next.